the connection between a musical instrument and a hydrogen atom. One follows the law of classical mechanics while other follow the quantum mechanics. But there is one phenomena that is common in both, and that phenomena is beating at the very heart of all of them. Welcome to this video. In this video, we will be going to see how standing wave is responsible for such a ear-pleasing music like this, or an irritating sound like this. It is also responsible for the quantization of energy in an infinite potential well, the quantum harmonic oscillator, and a hydrogen atom. The S, P, D or any other orbital that we have seen in the hydrogen atom are nothing but the different notes of standing wave. Wave is a disturbance that travels through a medium. Mathematically, a wave is described by a wave equation. Here, Y represents which kind of wave we are talking about. I mean, disturbance of what? For light waves, Y is an electric field or a magnetic field. For the string wave, it is the actual displacement of the string from the mean position. For sound waves, it is the overpressure. And for the gravitational wave, it is the metric tensor. The wave equation represents how a wave evolved as a whole in space and time. The first picture that comes to our head when we heard this word wave is a sinusoidal picture. In reality, a source may not necessarily produce a sinusoidal wave unless it emits the single frequency. So, why do we study sinusoidal waves? The answer is hidden inside the Fourier analysis. A wave can be assumed to be made up of sines and cosines of different frequencies. Studying the sinusoidal wave and integrating those waves can help us to study almost all kinds of waveforms. One of the most interesting properties of a wave is standing wave. When a wave reflects back and interferes with itself, then we have a standing wave. Not all such interference produces standing wave. When the distance traveled by a wave before getting reflected is the integral multiple of the wavelength of that wave, then only interference of wave give rise to a standing wave. These standing waves could last forever as long as there is no energy leakage in the system. So fundamentally, a standing wave is nothing but the superposition of waves under some special condition. What will happen if there is no sufficient condition for the standing waves to be formed? Well, the wave will reflect back and forth until they destroy themselves, and in the end we will left with no waves at all. Let's take a guitar and pluck one of its strings. You will hear a sound wave. Both the end of the string are tied and their lengths are fixed in order to produce these standing waves. It may seem like string vibrate in some random waveform, but in principle, it is the infinite summation of several standing waves of sines and cosine. And from the mathematics of Fourier series, we can actually calculate it. But there is one issue with this. Is wave really made up of sines and cosine, or we assume it to be in order to reduce the mathematical difficulties? Well, it is not limited to the waves only. It is one of the unanswered questions of physics and mathematics. Why does the superposition works in general? Mathematically, it is the linearity of the equation which allows the superposition principle to work. But philosophically, we still don't know why does superposition works at all. Take a wind instrument, let's say a flute. When we blow the air in it, we get a spectrum of sound waves. These waves are also bounded, but this time there is no physical boundary present. Instead, the atmosphere itself acts as a boundary. These sounds are nothing but the superposition of standing waves. In the case of two-dimensional standing wave, we will take a musical drum. Did you hear that sound? In the case of two-dimensional circular disc or drum, instead of getting the superposition of sine and cosine, we'll get the superposition of Bessel function. Now we will enter into the quantum world. Here a particle is identified as a wave, and the evolution of those waves is governed by Schrödinger wave equation. Here y variable is a wave function. It is also called the probability wave. These probability wave also form the standing wave, just like the sound wave does in the musical instrument. If we take a quantum particle and trap it in an infinite potential well, quantum mechanically that particle is a wave which is bounded by infinite potential. Those waves reflect and interfere with each other, producing the standing wave just like any other wave does. But it is only possible for some fixed wavelength, and because the wavelength of wave is linked with the energy of the particle, only fixed quantized energy will have the capability to produce the standing wave. For the other energies, the wave will simply cancel out each other and we have left with nothing. No waves means we would never get a particle there if we do a measurement, and we would never get a particle with those unaccepted energy. In this way, the energy get quantized in quantum mechanics, and the same things applies for the 2D and 3D cases. But instead of the one-dimensional standing wave, we will get the two-dimensional and three-dimensional standing waves. In the case of the free particle, the waves are not bounded and there is no extending wave. Hence, the energy of those particles would never be quantized. Exactly similar phenomena applies for a quantum harmonic oscillator. Because the shape of potential is different in this case, the states are the superposition of harmonic polynomials instead of sinusoidal. But we still get quantized energy. This again proves that a general wave can be assumed to be composed of several other waves, like the Bessel function, the Fourier series, the Hermite function, etc. Let's come to a hydrogen atom. It is a three-dimensional infinite spherical potential with potential varies as inverse of radial distance. Take an electron and put it inside an atom. These electron waves will bounce back and interfere with each other, producing the standing wave. These standing waves are the superposition of the Laguerre function and the spherical harmonic function. So the conclusion of this video is that this standing wave act a kind of door which will take us from the classical world to the quantum world. The very word quantum in the word quantum mechanics itself says that there is a quantization of something, and that quantization arises due to the standing wave. So if you are a physics student and you are about to learn the quantum mechanics, I would suggest you to first learn the standing wave properly. Then it will going to be very useful for you. And one more thing that I wanted to tell you, that we in the previous video the previous video was about the equations, right? It was the first video of the equation, the untouched legacy. Our work is still going on, and very soon we are going to publish the second part of the video. So for that you can just stay tuned and turn on the notification, and if you are new to this channel, you can subscribe to this channel.